Greetings, this is Unit 1, Module 1, Session 2. The name of this home connection is Number Line Puzzles. It's a two-pager. Go ahead and put your name and number at the top, just so you get credit for all of the hard work you're about to do. Since this is the first home connection of the year, there's a little note to families, and it talks about how number lines can help you understand smaller to larger numbers, and how math facts are very handy for doing calculations. Okay, let's dig in. By the way, if at any point in time you would like to speed me up or slow me down, you can do that in the settings. Also, if you don't need help with this question, but you need help with one later, feel free to fast forward. So I have 2 times 4. I could think of that as 2 plus 2 plus 2 plus 2, or I could think of it as 4 plus 4. I kind of like think adding 4 plus 4 is a little bit easier. 2 times 4 is 8. Now, if that's counting 4 twice, then counting 4 3 times would just be adding 4 more, which is our 12 here. They've already done that for us. If I continue on my number line, well, after I've done 2 times 4 and then 3 times 4, I'm going to just do another 4 and do 4 times 4. So just like we said before, well, now I'm adding another 4 onto my number line, so that should become a 16, right? 4 times 4 is 16. Now, this is where we're going to have to make a little bit of a mental jump, because you could spend a lot of time maybe working too hard on this, or we could try to figure out if there's some sort of a pattern they want us to discover. Because look, they left out a whole bunch. They 5 times 4, 6 times 4, 7 times 4. They skipped all of those and went all the way to 8 times 4. Well, I can think of it a couple ways. I could know my math facts and say 8 times 4 is something. Maybe you know it. I could do 8 plus 8 plus 8 plus 8, because that would be counting 8 4 times. Maybe I come over here and I just keep adding 4, and I keep adding, oops, I need to learn how to write adding 4, and I keep adding 4, and then I keep adding 4 until I get the answer. Or maybe I could look at this pattern, and I'm going to circle these in green, or maybe put a box around them. 4 times 4, 8 times 4. I want you to compare the 4 and the 8. Wouldn't you say that 4 times 4 and 8 times 4, this is twice as many? Because if I count 4 4 times, and then I go count 4 8 times, well, 8 is twice as many as 4. So maybe I could think of this number as being twice as much. Or you could say doubling it. So I could say 16 plus 16 is going to be this answer here. So that's one way to think of it. Also, if you know your math facts, you know that 8 times 4 is 32. But either way, there's so many ways to solve this. That's one of the great things about assignments like this, is you can discover patterns. Okay. Now, there are a couple ways you could solve this next one too, and hopefully I can zoom in on here to make it a little bit easier to see. We said that 8 times 4 is 32. Well, 9 times 4 is just one more 4. So we could, if we wanted to, just go ahead and add 4 more, and then we would have what? 32 plus 4 is 36. That one might be a little easier than remembering the math fact of 9 times 4. Get the same answer, but maybe this, since these are so close together, it might be easier just to add 4 in your head to get this answer. And then last but not least, we want to know how many 4s you would count to get 40. What times 4 is 40? Well, interestingly enough, the difference between these two numbers is 4, right? Well, if I have 9 4s here and I add one more 4 to it, doesn't that give me 10 4s? I think it does. And you could also use your zeros rule. 10 times any number is the number with a 0 on the end. So that is correct. 10 times 4 is 40. Did I spend 4 minutes on this problem? Yes, I did. Could I have done it a little bit faster? Absolutely. But hopefully you noticed that we pointed out different ways to solve using math facts, just doing the long addition. We talked about the sequencing in the number line, comparing our multipliers, we talked about a lot. And so that gives you many options for these questions down below. Now, speaking of that, this one here, I'm going to give you a few tips on, and then I would like to see you complete it, okay? The beginning, I don't think you are going to struggle with. I think when you look at these here, you're going to see a pattern. We're counting by eights. That's not too bad. However, let me color this in red. I still want you to compare this 4 to this 8. Do you remember how we doubled up here? We doubled the 16 to get 32. You are going to double this answer to get to here. And then I want you to also consider how we solved the rest of these by thinking about the difference between the answer and the next answer. Okay, this might be one you could use your math facts on if you are a math facts wizard. What do I mean by that? If you know your ratio table for if you're counting by eights, then you know that 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, 5 times 8 is 40, so on and so forth. If you know your math facts that way, you could fill this in without even thinking about the factors. But if you want to go through this number line a little bit more sequentially and think about 8 times 9, 9 times 9, 10 times 9, then that might be a little bit better for you. At the end of the day, you want to be successful with your numbers using whatever strategies work for you. And we'll practice the other ones throughout the year to make you more comfortable. These are math facts. I can't really walk you through them other than giving you the answer. So I would like you to try your multiples of 8 in here, because it looks like we've just got lots of 8s that they want you to figure out. 8 times 2, 8 times 4, 8 times 8. But once again, there are patterns, okay? So if you know that 8 times 2 is 16, then 8 times 4 should be double this. And then whatever your answer is here, 4 is half of 8. So to get 8, we need to double the 4. So whatever this answer is here, we need to double it to get this answer. So right there, I'm starting to see patterns in the numbers that might help you if you don't want to count them the long way. What would the long way look like? Well, for this one, it would be 8 plus 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 8. That might take you a little while. But if you already know this answer here, double it, and you'll know this answer, okay? So if I were you, I would pause this video and spend some time looking at that line. There are a couple at the end that aren't 8s, but the nice part is if you start here, you can subtract 7. I'm going to say that one more time. If you know what 7 times 10 is, if you know your rule for zeros, then 7 times 9 should just be 7 less. Okay? Number 3, Roger's little brother Saul wants to know if 5 times 7, let me get my highlighter out here, is the same as 7 times 5. If you were Roger, how would you explain to Saul whether the equation is true? So if you know that 7, I didn't mean to do that in highlighter. Let me get my pen out. 7 times 5 is 35. That's a nice math fact to know. And you also know that 5 times 7 is 35. Well, how would you explain that to Saul? How would you say these are the same? And you could draw it out if you would like to. You could say, well, if you take 7 and you count it 5 times, you eventually add up to 35. And you get the same answer if you take 7 and you add it up 5 times. You can put it in whatever words or pictures you would like. Let's take a look at the next page. As usual, pause these videos if you feel like I'm going too fast, or go into the settings if you would like to slow me down. I try to go at a medium speed just so that I'm not making any of you fall off to sleep, but at the same time, you have the option to speed me up or slow me down in the settings. So I hope you take advantage of it. Each of the 29 students in Mr. Brown's 4th grade brought 2 notebooks to class the first day of school. How many notebooks was that in all? Now, this is going to be tricky because if you like to draw questions like this, well, then you might be tempted to draw maybe 29 circles. And I want you to just pretend that I'm drawing 29 circles. And then I put maybe 2 tick marks in each one, right? And then I have to count that 2 29 times. Woo, that's going to be a long problem. And that doesn't mean you will get the wrong answer. But in the previous question, we said that 29 times 2 is the same as 2 times 29. So rather than doing 29 circles, what if you did 2 circles that each have 29 in them? You're going to get the exact same answer. And this is called the commutative property, and we'll learn about it a lot in class. But for now, if you have the opportunity to do less work, do it. You could count 29 times, or you could flip it around and count 2 29s. And then if you would like to, I would highly suggest you stack and solve 29 plus 29, and you're going to use your standard algorithm for multi-digit addition, where you start with the 9s on the right, you add them together. 9 plus 9 is 18. I have to make sure that I carry the 1. Okay, make sure that 1 gets up top here. Now that I've added the 9s, I can now add 2 plus 2 plus 1, which is 5. Okay, when we write our answer in here that we like, consider it this way, only the equation here. So if we like this one, we'd say 2 times 29, and then our answer goes here. You said 58, and then what are we counting? It says up here in the problem, we are counting notebooks. It's nice to always be aware of what we are calculating, okay? Each of the students in Mr. Smith's class also brought in 3 pocket folders. So we already know this number, the number of students. We said that in the class that there are 29 students. So we need to keep that in our brain, okay? And they brought 3 pocket folders in each. Mr. Smith wrote a multiplication equation to compare the number of students to the number of pocket folders they brought in. Fill in the bubble to show what this equation means. So this here, right, would say that there are 3 pocket folders for all the students. There's 29 of them. So you're going to count 3 29 times. That would give us a total of 87 pocket folders. Now, what we need to know is which one of these is true using this equation. 87 is 3 more than 29. 87 is 3 times as many as 29. 29 is 3 times as many as 87. Wow. Well, let me work this out with you if that's okay. 87 is 3 more. Well, to me, more means plus. So that would be 87 is, equal is, okay? 3 more than 29. So 29 plus 3. Ooh, I don't know if I like that because 29 plus 3 is 32. This is not 32, so I don't like this choice, okay? 87 is 3 times as many as 29. So 87 is 3 times as many as 29. Holy moly, that matches this perfectly. So I kind of like that one, but just in case, let's come over here and take a look. 29 is, remember is equal, 3 times as many as 87. Whoa, 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 whoa. That's not what that equation says. That's completely backwards. So I do agree that this is probably what we want. Okay, I'm going to X that out just so I know I don't want to choose it. Finally, I know we're kind of past the 5-minute mark on this page, but this challenge may be quite interesting. It says, and let me find my arrow here. If 5 students each brought in 8 boxes, with 10 pencils per box. And 10 students each brought in blah, blah, blah. You know what? That's too much. I'm going to focus on the part that I can remember. If 5 students each brought in 8 boxes with 10 pencils per box. Wow. So we're trying to think in how many pencils there is. Well, let's talk about just one box. One box has 10 pencils. Each student is going to bring in 8 boxes. So how many is one student going to bring? One student, this is going to be a terrible drawing, but this is how I'm thinking. One student, hey, with a really long neck, is going to bring in 8 boxes, and I'm going to terribly draw these boxes. 1, 2, 3, 4, 5, 6, 7, 8. I'm trying to be fast. And we said that there are 10 pencils in every box. So one student brings this many. How many is that? Count them. 10, 20, 30, 40, 50, 60, 70, 80. So one student, how am I going to write this? One student has 80 pencils. How many is 5 students going to bring in? Well, that would be 80 times 5. How are we going to multiply 80 times 5? That seems kind of complicated. We could do standard algorithm, which maybe I will right here in the middle of this 0. Wouldn't that be kind of fun? So I could do 80 times 5 and do my standard multiplication algorithm where I first take 5 times 0, that is 0, and then I'm going to take 5 times 8, that is 40, so that's 400. There is another way to do it. If you pretend like this 0 doesn't exist, then your problem is just 8 times 5. 8 times 5 is 40, and then just put the 0 back on the end, and you get 400. And we'll talk about some rules with zeros and multiplication a little later in case you need a little refresher, okay? So right now, according to that, those 5 students brought in 400 pencils, and I'm going to mark that down here. Then it says, and 10 students each brought in 8 boxes with 5 pencils per box. Oh my goodness, that means I've got to draw again. So that means in this group, one student, if I draw maybe just a little smaller student here, they're going to bring in 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8, with 5 pencils in each box. I like this because I like counting by 5s. I can do that pretty quickly, and I bet you could do that with me. Let's go for it. 5, 10, 15, 20, 25, 30, 35, 40. So these students brought 40. One student, 40 pencils. And we said that there are, look at this up here, 10 in this group. So 10 students each brought 40. 10 times 40. Now let's see, where am I going to do this? Maybe inside this 0 right here. Okay, so if I do 10 times 40, I'm going to show you kind of another trick. Forget this 0, forget this 0. What is 1 times 4? 1 times 4 is 4. Now I would like you to put both of those zeros back on the end of this number, and you get 400, which is the same as the other group. Okay, so this group here has 400 also. So if the question says, how many pencils did they all bring in? Well, look at my highlighter right here. That's not a highlighter. Oh my goodness. I've got 400 and 400. Add them together. 400 plus 400. Oh, that's not a pen. Oh my goodness, I'm struggling here. Here's my equation. 400 plus 400. The answer would be 800 pencils. Make sure you label it. This was a long question. Maybe you got it before I did. Maybe you wanted to follow along that whole time. Notice that I did lots of drawing. There's nothing wrong with that. It helps you visualize what you're doing. In this particular question, we had 2 big steps, and each of those steps had 3 smaller steps. So that's 6 steps in all. with a 7th step of adding, that's a lot of steps in one problem. But notice that it didn't it didn't include anything we could not do. We just needed to be just a little diligent and focused in how we broke down the question into its little bits. Okay? By the way, that's too many pencils to bring to school. Don't do that. Okay, if you have any questions about your math homework, please ask a math wizard. If you've got one in your family or a friend, that's great. If you want to ask a teacher, please do. Teachers love to answer math questions. Okay, check you later.